Hi everyone. In this session we are going to discuss reverse biasing of PN junction diode. In the last class we have discussed forward biasing. If you have a clear idea about forward biasing, then this topic will be very easy for you. Okay, let us start the discussion. Reverse biasing. This is our PN junction diode. Here it is P region, it is N region, and you can see a depletion layer here. When we are connecting this P region to the negative terminal of the cell and N region to the positive terminal of the cell, then we can say that this diode is in reverse biasing. P region should connect with negative terminal of the cell and N region should connect with positive terminal of the cell. Then it is called reverse biasing. Here you can see that the negative terminal of the cell is connected to P region and positive terminal of the cell is connected to N region. Now what is going to happen when we are switching on? Now the switch is on. We know that in P region the majority carriers are holes. In N region the majority charge carriers are electrons. P region is connected to the negative terminal of the cell, N region is connected to the positive terminal of the cell. So what is going to happen to these holes and electrons? The negative terminal of the cell will attract all the holes in the P region and positive terminal of the cell will attract all the electrons in N region. Because of this attraction of cell, what is going to happen? All the holes and electrons will move away from the depletion region and the depletion region will expand. Here we can see that the depletion region is expanding. If the depletion region is expanding, there will be more barrier potential. If there is a high barrier potential, the resistance is high. Holes and electrons cannot pass through this depletion layer. They cannot jump through this depletion layer. So it is an insulator. In reverse biasing, the PN junction diode is an insulator because the depletion layer is expanding, there will be high resistance. Let us write it. In reverse biasing, positive terminal of the cell is connected to N region and negative terminal of the cell is connected to the P region. Depletion layer is expanding in this situation because of the attraction of the cell. Resistance of the layer will be very high. Here PN junction is acting as an insulator. So depletion layer is expanding. Now we have a wide depletion layer. Because of this depletion layer, it is an insulator. So in reverse biasing, the current is not flowing through the diode. What about minority charge carriers? We were talking about majority charge carriers, but there are minority charge carriers. The minority charge carriers, what is happening to them? Let us discuss that. This is P region and this is N region. In P region, holes are the majority carriers and in N region, electrons are the majority carriers. You can observe the connection, it is in reverse biasing. In P region, electrons are the minority charge carriers. Now we are going to talk about minority charge carriers. In N region, holes are the minority charge carriers. Here you can see the minority charge carriers now. Here electrons are the minority charge carriers. Here holes are the minority charge carriers. Now in the depletion layer, this is negative and this is positive. There will be an electric field. The electric field is from positive to negative. Electrons can move opposite to the electric field. Here you can see the electrons. The electric field is from positive to negative. Here there are electrons. Electrons means minority charge carriers. From here the minority charge carriers will move from P region to N region because there is an electric field. Electrons can move opposite to the electric field. So here you can see that the electrons are moving towards the electric field. Because of this movement, because of this minority charge carriers, there is a current. This current is known as reverse current. Why it is called reverse current? Because it is happening in reverse biasing. Because of this minority charge carriers, there is a current. That current is known as reverse current. Minority charge carriers will move. There will be a current because of the minority charge carriers. This current is known as reverse current. So in reverse biasing, there is no current because of the majority charge carriers. It is an insulator. Because of the minority charge carriers, there is a small current. The current will be in microampere. Very small current. We can avoid this one. Generally we can say that in reverse biasing, diodes are insulators, but in some situation we will use this reverse current also. In next class we will be discussing forward characteristics and reverse characteristics. Thanks for watching.